So my name's Lisa Aish. I'm a PhD student at Colorado State in the Department of Soil and Crop Science, and I'm looking at cover crops as a potential solution for soil health restoration in dryland cropping systems on the Colorado Plateau. So I actually do my research in Yellow Jacket in Colorado, but we work with farmers that extend into San Juan County in Utah. So I guess we're all familiar with the Colorado Plateau and the little annual precipitation that it receives. Many farmers in this region also don't have access to irrigation and rely on dryland farming, which is why we're all in this session and why we care about dryland farming. And as a result, many farmers rely on a 14-month fallow period in between cash crops to recharge soil moisture and take advantage of the low amounts of precipitation that the area does receive. So over time, this has led to a lot of soil erosion, and now we're in a situation where soils are highly degraded in the area. So our project is exploring cover crops as a potential way to mitigate a lot of the challenges that local farmers face. In other regions, cover crops have been shown to have several benefits which seem to directly address a lot of the challenges. Some of which are providing soil cover to prevent erosion. Cover crops can increase soil organic matter levels or fix nitrogen in the case of planting legume cover crops. And they also have been shown to increase soil water retention. So in the monsoon season, like we're in right now, the soil could actually capture more rainfall and have less runoff. But they also imply an increase in water consumption because cover crops take moisture to grow, and you limit the amount of soil moisture recharge associated with the fallow period. So that could represent a trade-off and a barrier to adoption of cover crops in a semi-arid region like the Colorado Plateau. So we aim to evaluate how cover crops impact soil health in such an arid climate. They've been studied in more humid regions like the Northeast or the Great Plains. So we kind of want to see in a more moisture limited environment how they impact soil health. And we want to evaluate what the trade-off is in terms of cash crop productivity and whether cover crops are economically viable in this area. And we want to share these results with producers and local stakeholders to gain feedback on cover crop perception and eventual adoption. So we're doing this through a 3-pillar approach. We have ongoing experiments at the Southwest Colorado Research Center where we can employ a factorial experimental design and look at how specific management practices like planting window, cover crop species, and tillage regime can influence the impacts of cover crops. We also work with farmers throughout the Colorado Plateau who implement cover crops on a portion of their field and are asked to just continue with their typical farming practices. And that is with the intention of seeing how cover crop results apply to more of a real world setting. And then we get consistent community feedback, and that's important to ensuring that our results are actually pertinent on a local level. So we have 2 experiments on station. The first was started back in 2015, and it looks at 3 different fall planted mixtures against a fallow wheat treatment, which is the control. And we have 3 replicated blocks, and this is all under no-till management. And so again, this was started in 2015, so we're just coming out of our 3rd cover crop rotation. The second experiment is a little more in depth and was started a year later. It compares 5 fall planted and 3 spring planted mixtures against a wheat fallow control. And we're also looking at how no-till versus conventional tillage impacts the effects of cover crops. Here I show just one block of the experiment, so all 9 cover crop treatments, and then we have a split plot design separating conventional and no tillage, and that's replicated 3 times. So we're just coming out of the second wheat rotation. So like I mentioned, we also work with participating dryland farmers throughout San Juan, Montezuma, and Dolores counties. So they plant cover crops in replicated strips on their field, and then their practices span a wider range. Some producers are no-till, some are organic, they plant different cash crops, and then we go in and take yield, biomass, and soil health data over time. So this project goes through 2021, so these are just some of the preliminary results. These results are from the second experiment that I showed you, where we're looking at spring planted and fall planted mixtures. So fall planted mixtures are producing about 4 times the amount of biomass as compared to the spring planted mixtures. So within those planting windows, cover crop species selection doesn't look like it has much of an effect on overall cover crop biomass. And a big reason for that is that in the fall planted mixtures, species are actually being outcompeted by volunteer wheat and weeds in many cases. And then this is reflected in subsequent wheat yields, where the wheat in the fallow treatments is yielding significantly more than in the fall planted treatments. And then spring planted treatments are yielding somewhere in the middle. And so when you actually correlate the cover crop biomass with the subsequent wheat yield, there's a pretty nice linear regression with an R-squared of 0.53. So there's a pretty significant relationship between cover crop biomass and the subsequent yield penalty. So this could be a way for, if you wanted some of the benefits in terms of soil health or maybe just soil cover, you could consider planting later in the spring, or you could terminate earlier and then have less of a wheat yield penalty. So what is causing the wheat yield penalty following cover crops? So as we know, moisture is the primary limitation in the region, so it's not a surprise that we're seeing decreased soil moisture with the cover crops. Particularly in the fall planted cover crops, which is mixes 1 and 5, shown on the left here, you see much lower soil moisture throughout the soil profile. And then the spring planted mixtures, which are the blue and green lines, are in between the fall planted and the fallow. And we're also seeing a reduction in available nitrogen. So this is measured at 2017 wheat planting and showing how much nitrogen is actually available to the wheat, since a lot of dryland wheat farmers don't fertilize in this region. So a lot of nitrogen's being immobilized in the cover crop biomass. So you see a lot less soil nitrate in the fall planted cover crops, which are shown in red, than you do in the fallow, which is shown in green. But it's important to note, of course, that this isn't a loss of nitrogen from the system, and this will be mineralized back into the soil eventually, and perhaps in a timely way that could be beneficial to the wheat in the future. And so since these are dryland systems, cover crop biomass is usually very dependent on the year in which it's grown. And particularly the precipitation amounts and distribution patterns. So in 2016, we got really good cover crop biomass between 4,000 and 5,000 pounds per acre, which is definitely a significant amount. But then in 2018, this was following a severe drought in the area, and so we were only averaging a little more than 1,000 pounds per acre. So this is reflected then in the wheat yields, where there was a 25% wheat yield penalty following all that cover crop production. And then in 2019, there actually wasn't a wheat penalty, and the cover crop treatments actually yielded slightly higher even than the fallow, which is shown in the purple bar. So we're seeing similar trends on farm too. So in 2016, farmers similarly had a lot of biomass production. And so they also saw on average a 25% reduction in wheat in the cover crop plots. And this is averaged across all of those farm sites that I showed you in the map. And then in 2019, this was following very little cover crop biomass production. So you see a slight reduction in wheat yield, but the differences are not significant. So we're also monitoring soil health metrics, and we know that changes in soil health take several cycles to show up, and particularly in arid regions. So we still have yet to see significant changes. In experiment 1, which was started a little bit earlier, and it's gone through 2 cover crop wheat cycles now, we're seeing trends. So this is showing total soil carbon, and it's slightly higher in cover crop treatments. It's significant to a level of an alpha level of 0.1, but we're just going to continue to monitor this over time and see if the changes become more pronounced. And this is soil aggregation. This is showing mean weight diameter in the cover crop versus the fallow. And again, there's a trend, but this is not yet significant. So the project is going to be followed through 2021 at least, with possible extension. And so we're just going to see whether over time the soil health improves and whether that's enough for farmers to justify taking a little bit of a wheat yield penalty in the shorter term. So with that, I'll take any questions. Thanks a lot for your attention.